Thank you everyone for joining. This meetup is organized by the Cloud Native Computing Napoli. So it's a local user group based here in Napoli in Italy, run by me and Domenico, as you can see on the call as well, and with some people, some locals. Of course, this is our first time that we have one of the meetups as virtual. So usually we have meetups here in Napoli, hosted by some companies, sponsor who are, yeah, we have the sponsorship for them. And we decided to try this kind of new experience to host this meetup as virtual in order to have the opportunity to have to get more people, so not from Napoli here but even from abroad, and at the same time having some international speakers, so people from abroad as well. And we will have Shubham today. So I will not take that much from me. I would like to hand over to Shubham as soon as possible. Uh, as I already mentioned, we are based in Napoli, in Italy. This is a meetup, actually is one of the official meetup of the CNCF Foundation. So CNCF Foundation has different user groups across the world. And our is one of them. So it's an official CNCF user group. Of course, it's focused on the cloud native technologies and everything related to the CNCF Foundation. So main projects like, Kubernetes, Prometheus, on, of course, even Strimzi. So the one that we are going to to listen about today. You can, of course, join our community group. You can see the link on this slide. Even if you are not in Italy, even if you are not based in Napoli, I think that we are going to have even more virtual meetups. So even if you subscribe, you can get, information about new meetups that we are going to organize, and you can get news. We are on Twitter. That is the Twitter handle account. And we are of course open to get ideas. So if you want to know more about some specific technology in the cloud native landscape, if you want to be a speaker, so even if you are not here, and we can organize a virtual one as today, you can propose a session. So please do. You can contact us. And other than this, I will say that we also have a GitHub repo. In this GitHub repo, we are going to put all the material that it's coming from. You see all the previous sessions, the previous meetups that we had in Napoli in the past. And of course, it's ready, all the stuff that we are going to upload after this meetup, with the slides from Shubham, even the demo source code, and everything that Shubham is going to show right now for us. So I will not keep more time. I would like to hand over to Shubham. There is just one information for you. There is a Q&A button, so you should see that button. If you have any question, we will monitor it. We could answer the questions in the Q&A section, or we can just leave that question but at the end for Shubham to answer them. So any other information you want to know, just please write on the chat. And as I said, for question, just use the Q&A panel. At this point, it's over to you, Shubham. I will stop sharing. You can start sharing, and we can just start.
Thanks, Paulo. Thanks for the warm introduction, and I hope you all can see my screen now. Is it visible to you?
Yes.
Okay, so welcome everyone to today's session. And in today's session, we are going to talk about how you can deploy Kafka on Kubernetes with the help of Strimzi. So, just before that, talking briefly about myself. So, as Paulo introduced me, my name is Shubham, and I work as a software engineer at Red Hat. And I mostly work on the managed application services part of the team. And at the same time, I love to contribute to open source projects like Debezium, etc. So if you are interested to collaborate on some open source project, or you would like to collaborate on Strimzi someday, then please do contact me. So now let's get to the agenda and let's talk about what we are going to discuss in today's session. So the first point on the agenda would be a brief introduction to Kafka and Kubernetes. So for the users who have never worked with Kafka or Kubernetes, I would just give you a brief about how what Kafka is, how it works, and like what Kubernetes is, and then we can jump on to why we basically run Kafka on Kubernetes, right? Like this is something we need to know, because you until unless you don't know, why would you do that, right? So we will go deep into it. We will also discuss how many challenges we generally get when we are trying to deploy Kafka on Kubernetes. So we're going to discuss that. And after that will come the time when I'm going to show you how Strimzi makes all these challenges way too easy for you. And at last, after discussing all about Strimzi and stuff, we are also going to have a demo session. So yeah, let's dive right into it. So, what is Kafka? I think some of you have already heard about this term Kafka. And yeah, for those who don't know about Kafka, Kafka is basically a distributed messaging system which is based on publish subscribe model. So basically, there is a producer who is publishing messages on some topic, and then on the other side there are consumers who can subscribe to these topics, and then they can exchange messages between them. So just a publish subscribe model. At the same time, when you are working with Kafka, it's really scalable. For example, if you have like high load traffic and you have your Kafka cluster up and you need to manage all this traffic now, right? So you can easily scale your Kafka clusters, like increase the brokers, and the job is done. And at the same time, it's also fault tolerant. So what do I mean by fault tolerant? Let's say if one of your broker goes down, then no problem. Your Kafka cluster is still alive, and you can still like do the message sharing between the producers and consumers, because we have something called partition replicas on other brokers also, which we are going to discuss later on in the slides. So that is how Kafka is very fault tolerant as well as scalable. And Kafka is not just that. So earlier, Kafka just used to be a distributed messaging system. Like it was like you just do this producing messaging, consuming things. But now it's not just that. Now it has become a whole integrated ecosystem where you have a lot of components coming with Kafka. For example, we have the consumer and the producer API. With the help of these APIs, what you can do is, like, if you are like trying to create an application maybe in Java, and you want to like send some messages, like a basic application where you are sending and consuming messages, so you can do this easily with these low level consumer and producer APIs. Then we have mirror maker. So if you want to mirror your Kafka cluster from one data center to the other data center, you can do that easily. We also have Kafka Connect. So what does Kafka Connect do? So it helps you move your data with the help of Kafka. So if you have like two databases maybe, and you want to like move the data from one DB to another one, so you can use Kafka Connect to do these stuff. And if you want to do some complex analysis, like on some real time processing of data, like while Kafka is ingesting these, like the real time data, and if you want to do some filtering, mapping, etc., some sort of complex processes, so you have the Streams API for it. So I mean, there is a lot of things going on with Kafka now, right? So, and there are other third party tools also which Kafka provides. You can always use them. So this is Kafka in a nutshell. So it's basically giving you a lot of things now, and it's a big integrated ecosystem. And now let's talk a bit about what Kafka topic is. So producers and consumers, as I like talked about it in the previous slide. So producers and consumers are able to talk with each other with the help of these topics. So you can think of these as commit logs, where the producer are publishing something onto these files or logs, and the consumer are consuming them. And topic is nothing but it's just made up of like partitions. Like what you can say is Kafka used this method called sharding, where this topic is made up of like partitions. Like if you say that I'm going to create a Kafka topic with three partitions, so you will have three partitions for that partition replicas. And then if you say I want three replicas, so you have three partitions, and the partition replicas for these three will now be assigned on to other brokers also. So you can mention the partitions, how many partitions you want in your topic, and the replicas. So due to this thing, like these partition replica thing, you get the fault tolerance. Like if one of your broker goes down, no issues, because you have the partition replica for that same thing on some other broker. So you can always like do the producing and consuming via that broker now. So that's how Kafka is way to fault tolerant, and that's how basically Kafka topic works. Now, since we have a brief knowledge about how Kafka works and how the producer and consumers are talking with each other and stuff, so now let's deep dive, let's dive into what Kubernetes is. So I think you might have heard about Kubernetes, and Kubernetes is basically an open source container platform, or you can also say it is something which can help you automate, scale, and deploy all your like automate, scale, and deploy your containerized applications easily. So with Kubernetes, you don't have to care about your underlying hardware. So doesn't matter whether you're working on bare metal, you are working on some other OS or some other stuff, some other platform, you don't have to worry about that software. If you have Kubernetes underneath your application, then everything is gonna work fine for you, right? So that's how powerful Kubernetes is. So it basically helps you like do everything if you have your application containerized. So just containerize it, push it to like give it to submit it to Kubernetes, and everything is done. Now, since we talked a bit about what Kafka and Kubernetes is, so now let's discuss about why Kafka on Kubernetes, right? So, first of all, Kafka is a very highly designed, distributed, and scalable platform. And even the operator workloads which come with it are distributed and scalable. So when it gets combined with Kubernetes, what you get is a great infrastructure abstraction, as well as if you are doing some cloud native development. For example, let's say uh, like running your application on other cloud providers. So if you want to do that and you have Kubernetes, so as I said, you have that abstraction, right? You don't have to care about what's the underlying hardware. You just like put Kubernetes under your application, and then you are ready to like move it across any premises, public, private, or hybrid cloud. So enabling the cloud native development for you. So this is why we generally deploy Kafka on Kubernetes. So at the same time, it's very easy for me to say, oh, I'm going to deploy Kafka on Kubernetes, it's going to be so easy. But it is not that easy as it sounds, right? Everything sounds easy when said, but when you do the practical, it's completely opposite. And why I say that? Because, when you are working with Kafka on Kubernetes, so first of all, you have to have the knowledge of Kafka as well as Kubernetes. And at the same time, when you are deploying that Kafka on Kubernetes, you have to make sure that your brokers are able to connect with each other, your producers and consumers, they are able to connect with the broker, right? So to operate and to manage Kafka when you are inside like working with Kubernetes, it gets tough. So that is one issue. And at the same time, if you have some time constraints, so let's say you get a very short time to like deploy Kafka on Kubernetes, and they just said, oh, just do it. So it's gonna be complex, and if it's complex, it's definitely going to be time taking, right? So is there some easy approach to deploy Kafka on Kubernetes? I mean, is there something? So yes, we have Strimzi. We have got you covered. You don't have to worry about anything now. So what is Strimzi? Strimzi is basically a CNCF open source project. So It's a great operator for running Kafka on Kubernetes. It is based upon operator pattern where this operator has the knowledge about your business, where your business is Kafka, right? So this operator is going to help you to deploy Kafka on Kubernetes. Okay. And at the same time, it's going to provide you a Kubernetes native experience. Okay. So one question that will come into your mind is that why? I mean, how can you say that it provides us Kubernetes experience? So if you have worked with Kubernetes, you already know that there are some Kubernetes native resources like pods, service accounts, your secrets, config map, etc. So when you're working with Kubernetes, these things are native to it. But at the same time, you have the power to extend the Kubernetes API. And by extending the Kubernetes API, you can like what Strimzi will do for you is like you can extend these Kubernetes API using CRDs, which are called custom resource definitions. So with the help of these CRDs, you can tell that okay, I'm going to create a Kubernetes resource of kind Kafka. So creating your own resources. So Strimzi provides you CRDs, for example, for Kafka and for other Kafka related components also, which we are going to talk about in the later slides. So basically, Strimzi is providing you these CRDs by the help of which you are getting the Kubernetes native experience. So you just have to write down things in your custom resource definition and then provide it to the operator, and operator is going to do all the stuff for you. You don't have to worry about anything. So that is why your CRDs are providing you native experience. Uh, at the same time, you have built-in security with Strimzi, like you can, if you want TLS certificates, etc. At the same time, you can manage authentication or authorization, what type of authorization or authentication you want. So you have a great security, and at the same time, it's easy to use. And why do I say easy to use? You're gonna see it in the demo. The next slide is an example of custom resource definition. So this is a small custom resource definition, which is of kind Kafka. So basically, I'm writing this resource and telling Kubernetes, okay, this is a CRD, which is of kind Kafka. And now I can mention things like what is the Kafka version, which I'm going to use, as you can see here. Then how many replicas I want in this Kafka cluster. And at the same time, the list about the listeners. You want the TLS listeners, or you just want a plain listener. You can like configure it, and it's all upon you. You can also configure the Zookeeper configuration, and it's not just that. You can also like manage, like write down about storages, with type of storage you want, persistent, ephemeral, etc. So this is a basic example of how a CRD looks. And these custom resource definitions are not just up to like limited up to Kafka. We have a lot of custom resources for other Kafka stuff also. Like for example, if you want to like you want your Kafka cluster to interact with the HTTP client, so we have the Kafka bridge resource, with the help of which you can like your HTTP clients can like interact with the Kafka cluster using the HTTP protocol. Then we have the Kafka topics and the Kafka user custom resource. So this is to manage your topics and your users, like the Kafka users. So by the help of these like CRDs, you can update it, like tell that what your Kafka user should be, what type of ACLs you want to provide to it, etc. And with the then you have the Kafka mirror maker custom resource, like for mirroring data, as I told. So for that also we have a custom resource. We have custom resource for rebalancing also. So when it comes to rebalancing, we have a Kafka rebalance resource. So once you tell it that how you want to rebalance, so after submitting the Kafka rebalance resource, we have some integration with cruise control. So for rebalancing, you just provide the Kafka rebalance resource, and then cruise control is going to come in and do all the rebalancing job for you. And it's very easy, right? So that's going to save you a lot of time. So now we have discussed a bit like about how CRDs work, how many types of CRDs we have. So Now let's dive into how basically Strimzi works and what are the operators present in Strimzi. So with Strimzi, we have these three operators: cluster operator, user operator, and the topic operator. So what the cluster operator does is that once you write your Kafka CRD, you're going to provide this Kafka custom resource to the cluster operator, and then based on this custom resource, what the cluster operator will do is it will deploy your Zookeeper pods, your Kafka pods, and another pod which is called the entity operator. So this cluster operator is gonna do the job for deploying these things. And yeah, for now, you can if you want to like use craft, like if you like we know that Kafka has moved, like now Kafka is ready with you know craft. So if you want to try craft with Strimzi, you can do that. So it's it's a use case which can you can easily use. Then you like once your cluster operator has deployed the pods for Zookeeper and your Kafka pods, then this entity operator pod is basically like this entity operator container basically contains two pods, user operator and the topic operator. So basically these two operators are like contained in and these two pods are contained in a single container, which is the entity operator. So user operator basically manages the user custom resource, and the topic operator is going to manage the topic custom resources. So this is how basically a Strimzi works, like feed the Kafka custom resource to the cluster operator, and then it's gonna deploy your cluster based on it, and then you have the entity operator managing the user and the topic users and topic CRDs for you. Okay, so after talking a lot about Strimzi, so you might be thinking this guy kept talking a lot and now what? So let's go through a demo where I will show you how you can install the operator. Then we are gonna see how the Kafka resource look like. We are gonna deploy some Kafka topics, Kafka user resource, and at last, what we'll do is we will deploy a Hello World application where we'll be producing some Hello World messages and then consuming it using the consumer. So let's dive into the demo now. Okay, so I am already connected to my Minikube cluster and I have my Strimzi operator pod up. So you can see that like this. So I have my Strimzi cluster operator already installed here. So if you want to like deploy the operator, you can use either the Helm charts. If you want to do it using the YAMLs, then you can go to the GitHub page, and from there you can see how to deploy the pods, etc. So we have multiple ways to deploy the operator. You can even go to the website, the quick starts, and from there you can get the script from where you can like get the cluster operator running. Now, moving on to like after the deploying the operator, what was the next step, right? The next step was to deploy the Kafka custom resource. So for that, I'm gonna do kubectl create. I'm gonna create the Kafka resource. So I'm gonna use TLS authentication with it, and let's deploy it. And uh, okay, so first let's go through how this Kafka custom resource basically look like. So here it is. So basically this custom resource contains the cluster name, the version, how many replicas we want, what type of listener we want, authorization. Then we can change the configs, we can change the storage here. Then we have the Zookeeper configuration here at the same time, and this is the entity operator. So clearing it, let's see if the pods are running or up yet. So kubectl get pods, and in this project, okay, so the pods are still running. So as you can see, the cluster operator, what it did was it deployed the Zookeeper pods, and after the Zookeeper pods, what's the next thing it's gonna the next thing it's gonna do is deploy the Kafka pods, as you can see. So once these Kafka pods are in the running state, it's gonna deploy the entity operator pod as we discussed in the like how the architecture works. So I can also show you the Kubernetes dashboard. So here it is, like to give you a better visualization of things. So here is the Kubernetes dashboard, where you can see that the pods are coming up, and you can even see the logs, etc. Here regarding, let's say, if you want to see the cluster operator logs, here it is. And if you want to see if you want to check if there are any failures with the Kafka pods, etc., you can always check the logs from here. So this is one easy way to see if things are up and ready or not. So uh, you can always come here, see, and you can see that we have currently the images are there on Quay. So yeah. Okay, let's just wait for one pod. I mean, all these things also depends upon your connections. Like let's say if you have your connection is not so good, so it might take some time. So as you can see now, our Kafka cluster is ready. Just to be sure, you can do this to check if your Kafka cluster is now ready. And to do that, I'm gonna do this. My cluster. I'm just gonna see my cluster in my project, and I want it like this. So this is like our class Kafka cluster is now deployed. We have the listeners here, and as you can see in the status, it is ready, right? And the Kafka version which we are using is 3.6.0. So basically what the cluster operator did was it deployed things based upon the custom resource which you provided to it. So now, since we have all our pods like ready, so this is how everything is ready now. So now the next step would be, since we are using TLS, I'm going to like apply some, like create some user and some topics, and then the hello world application. So to deploy the topic, what I'm gonna do is kubectl create the project. The namespace is going to be the same. I just need to do this, and yes, so boom, I have deployed the topic now. And to see how the topic custom resource looks like, it's something like this. You can mention that is of kind Kafka topic, the metadata about it, the label is pointing towards the cluster, my cluster. Then you can mention about the partitions, that how many partitions your topic should have, and then the replicas, like how many replicas do you want for these. So we want 3 replicas. So now, since we have deployed the topic also, the next job is deploy the Kafka user. So let's do it like this. Go here. The namespace is still going to be the same. And here I'm just gonna do the user YAML. Let's see the user custom resource also. So the user custom resource looks something like this, where I am basically telling that the authentication is of type TLS, and there are the authorization rules that my user can read and write from the topic, etc. So you can change these rules as per your use case if you want. So yeah, this is how you deploy a Kafka user. So once you are done with these, let me show you also that how the secrets are generated by the entity operator for you. So here is the secret is going to be the same name as your user. So it's going to be my user. And let's like have something more elaborate on this. So it should be this. Okay, so for the user, this is the user dot the user key and the user cert which I'm gonna use with my consumer in the hello world application. So yeah, you didn't have to do anything, right? You're just writing the custom resources and deploying them. So everything is very easy up till now. Now we have our user deployed, we have our topic deployed, we have the cluster ready. What's the next thing? The next thing is deploying the consumer. So create the consumer for me, and let's just wait for the pod to be up. The consumer is going to be of deployment type, so it's basically a pod. So Here it is. The consumer is now up and running, and even in the in the dashboard, if you want good logs, if you want like, yeah, I want some easy way, not using the commands, you can always go to the dashboard and just check here what's going on here. So basically for now, you have the you have the the consumer subscribe to the topic, and in the same way, once this happen, like you can also create the producer, and the producer is gonna create the messages, and then the consumer is gonna consume them. So I mean, now is the time to deploy the consumer, sorry, producer. So here, namespace is going to be the same. So this is the hello world YAML, which is basically my producer. Let me just show it to you. So this is the hello world producer. In the same way, I wrote the consumer also. So you can see I am using my user certain key here. I mean, I didn't had to copy paste it some the key and the cert somewhere. I don't need it because I just mounted them here, and the Kubernetes API is going to do all the things for me. I don't have to care about that. So let's just check if our pod is running. And just the same way, for better logs, you can always go here and see. So you can see that the producer has started producing the messages, and the consumer should consume them. So in the logs, I see there is some, I guess there is some issue with the consumer. So I mean, the messages should be here instantly, and if it's not here, that's not going to be a problem. Let's do one thing. We can try deleting the consumer, and we can try to like see if we create it again and if things work for us. So I'm just gonna delete the consumer for now. Okay, the consumer. Wait. Oops. Uh, oops. Okay, my bad. I think the demo the demo gods are not with me, but yeah, I'm gonna try. I guess I must be doing something wrong with the command, but yeah, just to cover myself, I knew my destiny is not so good with me. It always plays with me, so I have my demo ready at the same time with myself. So I know. I mean, anything can come to you, right? So I created a small backup, and from here I can show you how you are gonna get the logs. I mean, the producing of the messages was going fine. There was some issue with the consumer, but don't worry about it. I have got you covered here. So once the producer is up and the consumer is up, and if Destiny is with you, you're gonna get something like this, where you are going to receive the messages. The value, as you can see, hello world 123, and it goes till 1,000 because I have configured the producer to produce 1,000 hello world messages. So this is how basically things would work if the destiny is with you, and when you deploy your consumer and producer, you're going to get this result. So as you saw, it was very easy to deploy things. I mean, deploying the operator easy. Just provide the custom resource, just provide the Kafka custom resource. The cluster operator is going to do things for you. You don't have to worry about anything. And also, the cluster operator is not just about deploying the pods like the Kafka pods, Zookeeper pods. It's more like for a certificate renewal and things like that. Kafka, like the cluster operator is there. It's going to handle all those things for you. So, coming back to our slides. So, this was the small demo where I showed you what a Kafka resource looks like, what a Kafka topic looks like, a user resource looks like, how you install the operator. We saw how basically a Hello World application looks when you are working with Strimzi. So this is how easy it was when you were working with Strimzi. And now for the next slide. So we just saw one feature, right? We just saw how TLS works. Like with Strimzi, we tried the TLS authentication, but it's not just about that. We have a lot of features when it comes to Strimzi. We have the scale up, scale down feature also. We have multiple storages. Like you can configure the storage. We have Kafka Connect, mirroring. If you want to play with authorization, you can do it. Image pull secrets. We have cruise control for rebalancing. So it's going to make things easier for you. Affinity, tolerations. We even have metrics which are provided to you via Prometheus, and you can like look like broadcast them on Grafana and see how your metrics are going on. So there are a lot of things you can do with Strimzi, right? A lot of features. So and I would say it's not just these. You will even get more if you work with Strimzi. And it's not just about features now. You can also integrate Strimzi with other projects. So we have some friends with us, right? So for example, we have the Helm charts, which are helping us to deploy the Strimzi operator. So if you want to deploy the operator using Helm chart, you can do that. With Kubernetes, with your Jaeger and with Prometheus, what you can do is you can use the metrics and then like show them on Grafana to see how your Kafka cluster is doing. Your and also for other Kafka component. It's not just for Kafka, for all the other Kafka components also. Then we have Open Telemetry and Jaeger for tracing your applications. We have open policy agents through like for authorization stuff through which you can decide whether the user is able to write through on this topic or not, etc. And then we have Kida. What is Kida? It's basically a CNCF project. So it basically scales your cluster based on the event. So it's the event driven scalable thing. So if you want to work with it, you can deploy the cluster using Strimzi, and at the same time you will have Kida to do the other stuff. So and there is Fluentd also, which is a Kafka support which you can integrate easily with Strimzi. So we have a lot of friends with us, right? And we also have multiple customers which are using Strimzi now. And yeah, what's stopping you? You can also be a part of us, right? So if you want to use Strimzi, you want to work on it, you want to like if you find some bugs, etc. on Strimzi while working on it, so you can always visit our GitHub page. And on the GitHub page you can create issues, you can collaborate with us. If you think there is some other feature which is missing with Strimzi, don't worry, come to us, we can discuss that. And maybe in the next release you get that feature, right? And we have our Strimzi page where you can go and get the quick start, so you can do that. We have a Twitter channel where we like basically post about the updates to Strimzi, the features, etc. And when we also have our YouTube channel which will tell you what are the new features that are coming in Strimzi. So there's like, for example, what's going to be new in the new release. So reach out to the community, let's make Strimzi an even bigger project. And yeah, thanks everyone for joining the session, and I hope every one of you liked it. And if you have any doubts and questions, we'll go through the Q&A and see if you have any questions or not. Thanks a lot.
So thank you, Shubham. It was a great session, great introduction talking about Strimzi. So I guess that yeah, you got covered everything about why it's really useful to yeah to use Strimzi to deploy your Kafka cluster on Kubernetes. Does Strimzi has a Slack channel, right? In order to
Yes, Strimzi
engage.
has a Slack channel. So if you have any questions, etc., you can come to our Slack channel and we can discuss things there. I mean, if you didn't got a chance to ask any question here, or the other session was like, I mean, you had so many things to digest, so you can digest the things. Come back on Slack and talk to us, and let's collaborate.
Yes, yes, yeah. Actually, there are no questions in the Q&A panel, so I guess that yeah, we are done with this. And yeah, again, thank you very much for joining us for your session. It was great having you, and I do really hope that people starting from this will try to use Strimzi to run Kafka on Kubernetes, and then they will start to engage with the community, the Strimzi community as well. So again, thank you very much, and see you the next meetup. And have a nice day.
Yeah. Thanks. Bye. Have a nice day.
Bye.
Bye.